Okay guys, following our conversation last Monday, we are solving some problems in this video so you can have more material to look or to study. In this first problem, 212 from Signal Engineering Thermodynamics 7th edition, we are asked to choose between two sites to get the best spot for power generation. We have been given the velocity, the average velocity of air, and the number of hours per year that this velocity is present. We are going to assume that we have a negligible velocity in other times, and we're asked to get the best site for power generation. And we have a hint here: mass flow rate of air is proportional to wind velocity. But we are not being told what is that velocity or how to get that. So we are going to get some assumptions. The first assumption that we're going to make is that air is an ideal gas and that temperature is 25 degrees. Pressure is 100 kilopascal, and this is for both sides. And the area of this power generation can be considered 1 square meter. Obviously this is very low, but since both sides will have the same number, we will have comparable results. Okay, with this ideal gas, we know that we can get the mass flow rate. Mass flow rate will be equal to density times velocity times the area. Velocity we know it's 7 and 10, but we don't know density. But density can be easily computed using ideal gas relation. Remember that this R is 0.287 kilojoules per kilogram Kelvin. Okay, so substituting these values, we can get that density is 1.69 kilograms per cubic meter. Now, the energy that we can get out of these turbines is converted from kinetic energy. So this kinetic energy, or this kinetic power, can be computed as mass flow rate V squared over 2, right, times the time that this is in effect. So if we substitute, we know that the mass flow rate, we need to compute it first, is 1.169 kilograms per cubic meter times the velocity that we have here. In this case, we're going to use the first one, 7 meters per second, times the area. And this number is this number will be 81.83 kilograms per second. So if now we substitute here, we will have, let me just move this a little bit lower so it's clear for us. So this number will be 8.183 kilograms per second times the speed, 7 square meters per square second. All this divided by 2. Now, kilograms meter square second is Newton. Newton meter will be joule. By second will be watt. Divided by second will be watt. So all of this is what? Time, the time that we have every year. So we have 2000 for this first one, we have 3000 hours per year. And this number 601,450.5 watt hour per year, and we can just move our decimal point here, so at the end we will have 601.45 kilowatt hour per year. So this is the first one. If we repeat, this is side 1. If we repeat for side 2, we will have that the anywhere power that we are going to get is 1,169 kilowatt hour per year. So because of this, side 2 is the best one. Thank you. Now the second problem we're going to solve is man who is pushing a cart. The man has mass at 80 kilograms, and the cart has 45 kilograms, and it's moving. We are asked to move that for 30 meters over a ramp that's applied 10 degrees from the horizontal. And we are asked to get the system, first the man, and B, just the cart. And so let's start by the man. Okay, when the man is moving, all the work that he needs to do needs to move its 80 kilograms plus the 45 kilograms. So the total mass that he needs to move is 125 kilograms, right? Now, let's do diagram here. Have the horizontal. It's our 10 degrees. And then we have this is the mass that we need to move in this direction for 30 meters. Okay, remember that the force that we need to apply is to overcome this force, right? The weight, the component of the weight in this direction. So let's do a diagram here just to find out the proper force to overcome. Okay, so we are going to draw rotated axis, we know that we have 125 kilograms. We know that we need to multiply this times the gravity acceleration to get weight. So we know that we have this angle repeats at the intersection of the perpendicular. So the perpendicular of this one is weight, the perpendicular of this line is here. So we have this. So the two components of this force will be Fy and Fx. So this Fx will be the weight times sinus of the angle. And we need to overcome this force. So, going back to our solution, the work that we need to do is the force times the distance that we need to move. Force, we already know that is the weight times sine of the angle times the distance, right? So substituting, we know that the weight is 125 kilograms times the gravity, acceleration due to gravity, times 10 degrees. All of this is the work times 30 meters. This is the distance. So the work that we are gonna find out is 6,388. Let's see our units. Kilogram meter per square second. This is Newton. Distance, it's meter. So this is joule, right? We have 6,388 joules. We can apply this. 1 kilojoules is 1,000 joules. We cancel this and we will have 6.39 kilojoules. So this is our answer. Sorry, let's move this. Have it in red. So this is for the name. If we do the same for the cart, the difference is now that the mass that we need to move, it's only 45 kilograms. The force that it will move the cart will be received from somewhere else, in this case from the man. So if we repeat the analysis, we will find out that this time the work will be 2.30 kilojoules. Okay, thank you.